So Mary
That's a good
Schweitzer,
point.
she finds all this soft tissue and she says that she appeals to what we call the iron preservation.
Mm-hmm.
What's that?
Well, okay, what she did is she did an experiment with some ostrich blood vessels, and she managed to extract hemoglobin from blood cells and pour a very concentrated solution of hemoglobin basically into and preserved ostrich blood vessels for 2 years. Well, okay, 2 years isn't exactly 68 million years. So it's a bit of an extrapolation. But what she proposes is that iron causes free radicals that cross-link proteins and make them more resistant.
So that's the Fenton reaction.
That's the Fenton reaction. But normally organic chemists use Fenton chemistry to destroy organic tissue. And there's certain things that have been found in Dr. Schweitzer's work that should have been destroyed if a Fenton reaction was occurring.
So in other words, she doesn't really know what she's talking about.
Well, I think I think it's inconsistent. You can't, once you propose a reaction, it's going to do what it does. Like, you can't say it's going to do this, but it won't do this thing. But we're observing these things are found. Therefore, it's good evidence that Fenton has not been responsible for preserving it.
That's interesting because I think if you go on 80s websites, they always appeal to this Fenton reaction. And what you're saying is that the Fenton reaction will produce byproducts that will actually degrade those biomolecules faster.
And I don't see how Fenton would actually preserve DNA because DNA is a totally different background. So not amino acids, a phosphate and sugar, and iron would not help preserve DNA.
And I think what's interesting is that many of these so-called ancient soft tissue that we find, it's not just in dinosaurs. So they can't just appeal to Fenton reaction for preservation in dinosaur bones because it's not just dinosaurs.
That's a good point too, isn't it?
In fact, I think that dinosaur is the least of the evolutionist worries because using the evolutionist dates, what's the oldest sample we have? It's actually 2.5 billion year old.
Whoa,
We have original biomolecules still. That's a huge issue for them.
And that 2.5 million years makes dinosaurs look like spring chickens. That's by evolutionary dating, yeah.
Right, and this is from algae and from other molecules. And in fact, I think if you take that as what it is, looking at the so-called geological column using evolutionist dates, it can go all the way down to the lowest layers of fossils, and we still find original biomolecules. That's a huge problem for them, I think.
Right. I think dinosaurs, of course, are the most famous of these ancient creatures, but I think what you say actually is more of a problem, yeah.
Yeah, so it's more than Mary Schweitzer, it's more than just dinosaur. This is a massive problem for evolution and for the idea of millions of years. So at this current time, we do not have just 1 or 2 papers. We have 59 documented cases in the scientific literature, circular scientific literature of dinosaur biomaterials, spanning over 31 different scientific journals. And like we explained, we don't just talk about dinosaurs, but we talk about marine reptiles and birds and things like that. We have 119 publications.
That's a lot. I think mosasaurs have had some things like even some of the eye proteins are still there.
Yeah, in fact, it's almost every other month that we have a new documented case in the scientific literature.
Because now I guess people are more and more expecting to find them. At one time, they wouldn't have been looking. And if you don't look for something, you don't generally find it. But now they're finding it, which I think is a tacit admission that Dr. Schweitzer did find what she claimed to have found.
Yeah, in fact, earlier on, we mentioned the database that we can